We're going to be looking at some examples where we're given the graph of a function f and asked to graph its derivative. To learn how to do this type of problem, let's look at some guidelines for graphing a derivative that's based on the original function's graph. Let's remember that the derivative is the slope of the function. If the slope of the function is 0, then the derivative is going to be 0 and cross the x-axis. If a function has a corner, that means the derivative does not exist, and you have to notate that by putting an open circle at that point. If the slope is greater than 0, the derivative is going to be positive and it's going to lie above the x-axis. Likewise, if the slope is negative, the derivative is going to be negative and lie below the x-axis. And then lastly, wherever you have the steepest slope, you are going to have the largest positive or negative value for the derivative. Let's first look at an example where we are given a function that's graphed in blue and a derivative that is graphed in red. We're going to use this example to learn how the graph of the derivative relates to the graph of the function. The easiest way to begin these types of problems is to first look at where the function has a slope of 0. Our function has a slope of 0 here and here. Whenever the slope of the function is 0, the derivative will be 0. And you can see that right here and right here because the derivative is 0 there and crosses the x-axis. To the left of the first 0, the function f has a negative slope, and that means that the derivative is going to be negative and lie below the x-axis. The same thing happens to the right. Here the function also has a negative slope, and the derivative lies again below the x-axis. Now let's look at what's happening between those two 0 points. Our function is increasing or has a positive slope, so the derivative has to lie above the x-axis. To see where it lies above the x-axis, what you can do is look at the function and see where it is the steepest. Here it looks like the slope is the steepest right at the origin. And the slope of that line is about 3, so the derivative is equal to 3 at that point. The derivative then is going to start at 0, go up to this point, and then go back down to 0. Let's now look at the graph on the right. We're going to do something similar. We're going to start by seeing where the function has a slope of 0. Our function has a slope of 0 here, here, and here. And at those points, our derivative is going to be 0. So the derivative is going to be 0 here, here, and here. To the left of our first 0, our function is increasing and has a positive slope. So that means that our derivative has to lie above the x-axis. Our derivative then is decreasing and has a negative slope, and it looks like the slope is the steepest right here. So our derivative is going to be the smallest right here, and it's going to come down here and then go back up. And then on the right-hand side, our function is decreasing here. So our derivative lies below the x-axis. And then here, our function is increasing with a positive slope, so our derivative lies above the x-axis, reach a maximum here, and then comes back down. Let's now look at some examples where we are only given the function and we want to graph the derivative. We're going to first look at the graph on the left. Notice on that graph that we have no point where the slope is equal to 0. But we do have 2 points, one here and one here, where our function has what we call a corner, and that means that the derivative is not defined at that point. So our derivative, when x is -2 and x is 2, is going to have an open circle. Right now, we don't know where to put that open circle, so what we have to do next is look at the slope of each 3 of these pieces of our function. Let's look at this piece first. That piece has a slope of 1, so our graph is going to be equal to 1 up to this point, and there it's going to be undefined. Now let's look at our second piece. That graph has a slope of -1, so our derivative is going to be -1 between here and here, and at both of the ends, we are going to have an open circle. Let's look at the last piece. This piece has a slope of 1, and our derivative is going to be equal to 1 at that part, and we are going to have another open circle. Let's now look at the graph on the right. Let's start by looking at where our function has a slope of 0. That occurs right here. So our derivative is going to equal 0 at that point. When x is positive, our function is increasing, and it looks like it has the biggest slope about right here. So we can go up here and say it looks like our biggest value of our derivative is going to be about right here. And then notice over here on the right that our slope gets really close to 0. So our derivative is going to look like this. It's going to come up and then go back down. The same thing is going to happen on the left. Our slope has the biggest negative value at about this point, and that's about right here. So our graph is going to look like that.
If this video has been helpful to you, please consider subscribing to my channel. Keep believing in yourself and have a great rest of your day.